Hello everyone. In our previous session, we discussed about containerization. We already have discussed about the virtualization. In last session, we discussed about virtualization. What is the basic concept of containerization? What are the architecture, use cases, tools, which tools we can use? Okay, we have discussed everything about the containerization. In this session, we will discuss about some more about orchestration. Container orchestration. What is orchestration? Container orchestration is the automated process for managing the life cycle of containers, especially in the large dynamic environment. It helps to deploy, scale, networking, managing container efficiently. Means just for the automation, you can say, is the containers. We already know what is containers, but for the automatic that process, we use the container orchestration. Clear? So orchestration is the process of automating the deployment, management, scaling, and networking of containerized applications. It simplifies the lifecycle management of containers. Means we have to create the container, but manually it becomes very difficult for us in a large deployment to keep focusing on one this container, one this container, one this container. So to automate this process, like we discussed in the cloud computing also, regarding the infrastructure management. Okay, now. So in the containerization, for the containerization, if you remember everything about the container, for the application deployment, so it simplifies the lifecycle management container to deploy, scale, and management of various environments to managing that particular container, automate the process. This allow automation, you can say, organization to deploy the software consistently across many different environments at scale. So orchestration, I'm repeating again, is for the automation of the container process. Correct? Like this. This is the orchestration tools. We will discuss what is the name of that. So it automatically configure the everything. Configuration of the container, availability, provisioning, scaling. When this container require more resources, resource allocation, load balancing, some on any application, sometime load is automatically going to increase, and health monitoring of that particular container. Everything is done by the orchestration tool. So to maintain all these containers perfectly and efficiently, this diagram makes you clear everything about the its total automation to take care for everything for that container that a user require for the application deployment and running it smoothly and efficiently. Sometimes load is going over on one container. How to manage it? What are the resource allocation there? What is the health of that monitoring health? What is the health of that container? So it is total automation process. Correct? Why do we need orchestration? Perhaps it's clear to you. While Docker, I told you that is a container type, or any other container application that you're using can run individual containers. Okay, if you are using simple containers application, any application, either Docker or Kubernetes, whatever, running hundred and thousand of containers across cluster become very difficult manually. So it requires automation. To manage one or two containers is okay. You can handle it manually. But when there is a hundred of or thousand of containers, it becomes very difficult to manually manage all that. So that's where the orchestration step in. Means first container word comes to optimize that as per the requirement to run the container environment keep running smoothly without any problem and efficiently. Orchestration is the automated process. Hope clear? So now the core features of orchestration. Either I have discussed everything with you still, like deployment feature. Auto match the rollout and rollback of application in a container. Suddenly overload on one container current configuration. It automates the process to increase that particular container. And when the load goes down, automatically roll back. Scaling, sorry, scaling, totally automatically scale up and scale down based on the load or any manual input. Load balancing, distribute the network traffic across the container to ensure high availability. Self-healing, you can understand well. Restart fair container and replace unresponsible one automatically. Management, configuration management. Manage secrets and configuration data separately from the application code. And service discovery, allow container to find and communicate with each other across the node. Here's one of the best benefit now. What you can do if you have a big application. So a normal system, you have to install that application in one machine. But what we can do for different applications, suppose one application have 4 or 5 features, like in billing case, how much sold out, how much stock come, okay, billing, delivery, payment process, everything is a different process of the same application. Again, saying sorry for the writing and drawing, not so perfect. Okay, so you can deploy the same application but different code. This particular container is responsible for billing. This is for the stock management. This is for the delivery process. So what happened if a case anyone is creating the problem? Suppose this billing section is creating some problem or delivery is creating some problem. It will not impact the other process in the application. Other process keep working smoothly. So self-healing and configuration man comes here. Service discovery allow container to find and communicate various across the node. Actually, if something goes here, something sold out, it will communicate with the stock management also. This stock has been gone, so we have left this stock. It will manage that. So one application, different codes for different purpose can be managed in different containers. If one of the container got some problem, become unresponsive, it will not impact the other parts of same application. Up clear? So this is the orchestration. These are the orchestration tool. One is the Kubernetes, one is the Swarm, and one is the Apache Mesos. These are some examples. Most widely used open source system supports advanced orchestration, native to Docker. That is a Docker Swarm, simpler than Kubernetes, but less feature rich. Apache Mesos, general purpose cluster manager, supports container via Marathon. So main is the difference. Like we're normally using Kubernetes and Docker. I have told you last time. So these tool we use that for the orchestration of that. Docker is less feature rich as compared to Kubernetes. So most prefer is the Kubernetes tool. Okay. Example like for Kubernetes you can say simplified flow. First deployment. Kubernetes creates and monitors and scale up and down. This is the actually practical process that I'm showing you. Does not require to explain it here. But still, what is the total process we do? Okay, deployment, create, monitor, and scale up and down as per the requirement. Means creating the auto scaling there. We discuss in the virtualization and cloud computing also. Auto scaling. So here also we can do with the orchestration in container case. Benefit I have already discussed. High availability of application, automatic fault tolerance, efficient use of infrastructure, supports for the DevOps and CI/CD pipeline, easier management at the scale. We already have discussed that. So this is regarding orchestration. Hope everything is clear. In next, we will discuss a small more topic that is the resource provisioning and resource isolation. What is the resource provisioning? Provisioning is the process of allocating computer resources. That can be CPU, that can be memory, that can be storage and networking to the application, virtual machine, container based on the demand. How to provision the resources from my basic hardware as per the requirement. That is known as the resource provisioning. If we talk about the provisioning type, by the name it's clear to you, provisioning can be the manual provisioning. Admin allocate the resources manually via cloud or virtualization. One is the automated provisioning. Use tool or scripts as needed. Dynamic or elastic provisioning. Resource scale up and down based on the usage. Common in cloud. So automatically we can automate this process, that which particular machine or application require how much resources from machine. That is the resource provisioning. Like for the cloud providers, we use the EC2 auto scaling process, Azure VM scale sets, and instant groups we can create. Suddenly some load become very much on one machine. So EC2 auto scaling automatically will add some more machines here. And when that particular load become down, it automatically roll back. Scale up and scale down, we already have been discussed when we are discussing about the cloud. One is the resource allocation, isolation, sorry. Understand? I have told you. Either on the same box, multiple machine is working here. On the same box, multiple virtual machines are here. So what happened? But this all goes from my basic hardware, basic resources. So it automatically isolate. It keep isolated from one another. What is happening in this machine does not impact on another machine. So ensure that different workloads, either on the VM or the containers, do not interfere with each other, even when running on same physical hardware. Key feature isolation security. Naturally, what is happening in the neighbor machine should not know about what is happening on second machine. Stability and performance. This is the purpose of isolation. So level, it can be OS level. In virtual, if we want to talk about the virtualization, then has its own operating system. But in container have the shared operating system. Kernel level, fully isolated by the hypervisor. But container use Linux namespace and C groups. Resource level, CPU, RAM, disk quota set for per VM. And here it is managed memory, CPU, network limits, everything via C group. Strong isolation via hypervisor. Weaker. Now it's not strong now, but improving with container runtime. This is the isolation level. Hope I have been clear about the what we are discussing. So first, resource provisioning from the basic hardware, then provision that as per the machine, then isolation, keep everything separate. Either can be the containers or can be the virtualized machine. So these are the two concepts here, isolation and provisioning. So what we have discussed in this particular video, we discuss about the orchestration, why we need the orchestration, what are the core feature of orchestration, tools we have already discussed. I've given one example also. What is the total process? First deployment, then create, monitor, and scale up and scale down with the auto scaling. Orchestration tool, then we discuss about provisioning and isolation. So this is all about virtualization, orchestration, and container. So thank you very much.